Hi, in this problem you'll see that like 3z1 and 4z2, that mod relation is there, and here you see that z1 by z2 and z2 by z1 is there. So let's try to find out that z1, z2. So consider the given relation because that's the given condition, right? So it's given that 3 times of mod of z1 is actually equal to 4 times of mod of z2. Okay. So that imply that let us calculate mod of z1 divided by mod of z2 is definitely equal to 4 by 3. Now we know that whenever we have mod of z1 and z2, that imply that it is actually mod of z1 by z2. So therefore it's imply that mod of z1 divided by z2 is definitely equal to 4 by 3. That's it. So what that imply? It's imply that complex number z1 by z2 has a modulus, okay, of 4 by 3. Okay, and also that imply that modulus of z2 by z1 is definitely equal to 3 by 4. That's good. Just reciprocate that. Okay. So now we have to find that 3z1 by 2z2. Therefore, we have to multiply it by 3 by 2. So that imply that 3z1, it's a constant, so not an issue. 3z1 by 2z2, that will be equal to 3 by 2 into 4 by 3, that equal to 2. And it's given that 2z2 divided by 3z1, that's actually you're multiplying by 2 by 3, multiplying by 3 by 4, that's equal to half. So we can easily understand that this 3z1 by z2 is a complex number with modulus 2, and 2z2 and 3z1 is a complex number with modulus 1 by 2, right? So let's do this. Okay, so let us consider that omega 1 is equal to 3z2 divided by 2z1, and omega 2 some other complex number, that is 2z2 by 3z1. Okay, here I made a mistake, that should be z1 by z2. And so this is the two complex number we consider. Also we have that omega 1 mod will be equal to 2 and omega 2 mod is equal to half. So these two complex number. And also one important relation we have between omega and omega 2. What's that? It says that omega 1 is equal to omega by omega 2, or maybe the reciprocal of it. So therefore we can consider this. If the argument of omega 1 is actually theta 1, so therefore argument of omega 2 will definitely be minus theta. So because they are the reciprocal of each other, right? So if it is e to the power theta, it will be e to the power minus theta and all that stuff. Okay. So therefore, using Euler formula, we can consider that the complex number, now we can easily consider that complex number omega 1 can easily be written as 2 e to the power I theta, or in other way, it can be written as 2 cos theta plus I sin theta. And the complex number omega 2 can be written as 1 by 2 e to the power minus theta. That gives you actually 1 by 2 cos theta minus I sin theta. That's it. So now what we have to find, our required complex number z is actually omega 1 plus omega 2. So let's take that real and imaginary part. So this is 2 plus 1 by 2 cos theta plus I 2 minus 1 by 2 sin theta. So that complex number became 5 by 2 cos theta plus I into 3 by 2 sin theta. So therefore that will be our complex number z. Now we have to find out the mod. So that's simple, right? We have to do the square. So therefore that mod z will become square root of 5 by 2 square. So 25 by 4 plus 9 by 4. That gives you 34 by 4, which gives you the square root of 17 by 2. And that's why for this particular problem, the mod of z is 17 by 2 or square root of 17 by 2. Hope you understood the problem. It's a simple calculation. Only the concept is that we have to approximate it, or we have to calculate this by the method of Euler formula, or you can apply the polar representation of it. Otherwise, the problem becomes little complicated. So let's have a look at that, and that's obviously clear the problem. Thank you.